What's up, Defenders? So glad to be back with you this week. This week, we're going to be continuing our 8-week series talking about God as the best explanation of blank. So, this week's argument is that God is the best explanation for the applicability of mathematics to the physical world. Now, check this out. I feel a lot of a connection to this argument, and as a result, I did a lot of studying on it, and I'm going to admit right now that I am not done researching this. I'm going to dig into this as deep as I can, but to keep up with my promise to you guys, I said, you know what, it is enough to make a video on it. Just know that I'm probably going to talk about this more in the future. As a mathematician myself, with a bachelor's in mathematics, a bachelor's of science in mathematics, with a focus on statistics, and then as a math teacher, the applicability of mathematics to the physical world is already something that is intuitively close to my heart. I actually think that studying mathematics had a huge hand in my coming to accepting Christ. So I want to do this justice, and that's why I'm probably going to be digging into it more and more in the future. That being said, let's go ahead and dig into the argument this week. The unreasonable efficiency of mathematics in science is a gift we neither understand nor deserve. This is a quote from Eugene Wigner. He was a physicist, and this quote comes from the 60s. I have, in researching this, looked up more evidence and more conversations on the topic, and I have found that in as recent as 2010, there are still articles in the philosophy of mathematics where people are talking about the fundamental problem in this, that we don't know, nor do we have any good explanation or good reason on a naturalistic worldview as to why the universe follows mathematical laws. So, the argument formally can be structured as follows. If God did not exist, the applicability of mathematics would either be a physical necessity or else a happy coincidence. 2. The applicability of mathematics is neither a physical necessity nor a happy coincidence. Again, just like we've done the last several weeks, we're going to look at these two premises and say, if they were both true, what follows by necessity? It's not a question of, are they both true? Not yet, but for the logical structure of an argument, does the syllogism hold what follows from these two statements? If God did not exist, the applicability of mathematics would neither be a physical necessity or else a happy coincidence. The applicability of mathematics is neither a physical necessity nor a happy coincidence, therefore, God exists. This is the argument in its syllogism form and its deductive form. Let's have a conversation about the premises. So, premise 1. If God did not exist, the applicability of mathematics would be either a physical necessity or else a happy coincidence. So, people will argue that mathematics reflects nature because mathematics is based on nature. This is a misunderstanding of the field of mathematics. It is very common that people think that we learn math by studying the physical world, that we come to our conclusions based on trying to map out the principles that we see in nature. And I will admit that this is frequently the case. Often, we do discover mathematical truths this way. However, it is not the only way that we discover mathematical truths. In fact, there are many, many mathematical truths that we discover that are completely counter to this worldview of what mathematics is. Mathematics fundamentally is not the study of nature, but in actuality, the study of nature is the scientific method, and the scientific method presupposes the truths of logic and mathematics. So we need math in order to do science. We need math in order to interpret the world around us. Even if interpreting the world around us gets us to new mathematical truths, it is necessarily the case that those mathematical truths exist independently of nature. This objection is a misunderstanding of what mathematics is fundamentally. So, this is a complete misunderstanding of the very nature of mathematics, and here are a couple examples of counterexamples. The concept of infinity does not exist in the physical material world. Inside temporal space-time, there is no such thing as infinity. There is no actual infinite in the physical world. The concept of infinity is a mathematical principle. It is the idea of an endless number of something, an endless set. This doesn't exist in the physical world. It exists only in the metaphysical world, in our mind, in mathematics. However, the discovery of the concept of infinity was necessary for the development of the theory of calculus. Calculus is a model that is used fundamentally for all sorts of aspects in the physical world. When you start studying physics, you necessarily need to use calculus, but the concept of calculus necessitated the concept of infinity, which does not exist in the physical world. So we did not get to infinity by studying the physical world because there is no concept of infinity in the physical world. But as soon as we got infinity, we were all of a sudden able to do more and learn more about the physical world. Another such concept are things like imaginary numbers and complex numbers. You have the square root of -1, which is an imaginary number. There are no physical representations of the complex numbers, but by learning the complex numbers, we're able to do a great deal in the actual world. It is actually the case that the study of mathematics is not studying the physical world, but rather an aspect of the metaphysical realm, namely logic. So if we don't get our concepts of mathematics by studying the physical world, then this objection to premise 1 is patently false. We do not learn mathematics by studying nature, at least not always, and not fundamentally. And conceptually, it's not a necessity. However, when we study mathematics, it does tell us something about nature, and that is the very oddity that constructs this argument. So let's look at premise 2. The applicability of mathematics is neither a physical necessity nor a happy coincidence. Let's talk about a physical necessity. So, mathematical objects are by definition abstract objects. What is an abstract object? Here, let me tell you. An abstract object is a non-physical, non-mental object that exists outside of space and time and is wholly unextended. So, this means that they can have no causal relationship with the physical realm. Abstract objects are, you can think of them, I don't think this is perfect, but it's helpful to get the idea. You can think of them as imaginary. They're things that exist in the mind. They're things that exist in the metaphysical realm. They don't exist in the physical realm. And because they don't exist in the physical realm, they have no causal relationship with anything in the physical realm, which means that mathematical objects cannot have a causal relationship with the physical world, which means that the physical world does not necessitate the mathematical laws, and mathematical laws do not necessitate the physical world. So it is fundamentally the case, because mathematical objects are abstract objects, that they cannot exist or have the relations they have with the physical world by necessity. So it's not the case that it's physical necessity. Is it by coincidence? Well, let's think about this. I'm going to give you just a couple examples of the consistency that we see from mathematics to the physical world. For example, quaternions. So quaternions are the result of taking the complex numbers further, where complex numbers take the form of a plus ib, where a and b are real numbers and I is the square root of -1. Quaternions have the form of a plus bi plus cj plus dk, where the rules are that I squared equals j squared equals k squared equals I times j times k, which equals -1. A, B, C, and D are all real numbers. So, quaternions were a mathematical game trying to take the abstract objects trying to take the complex numbers into a higher dimension and realizing that you had to skip 3D and go to 4D to make it work. Next. So, these were constructed in 1843, and we've discovered very recently as the 1990s, that they are actually valuable for fields like computer graphics and robotics, which nobody expected. People expected it to be a game. But we realized that it followed a mathematical law that we could construct the quaternions, and it was literally over 100 years later, over 150 years later, that we realized they actually have a use case in the real world. That is an amazing coincidence. That's one. Then there's also the field of topology, which was invented by Euler in 1735 and then named topology in 1847. It's the study of geometric properties and spatial relations that are unaffected by the continuous change of shape or size of figures. So we're looking at the fundamental constructions. We don't care about shape, we don't care about size. So for example, if you have a three-dimensional object that has a singular hole in it, you could say that makes a donut. Well, that also actually creates a coffee cup, because coffee cup is a three-dimensional object with only one hole that goes through it. This hole stops. So topologically speaking, a donut and a coffee cup are the same topological object. This field was invented by Euler, like I said, in the 1730s. And today, the study of topology has been proven very useful for studying DNA, for computer science, for robotics, for engineering, for the way brain scans work, for the way that cell phone network coverage works, for digital photography, and so much more. Topology is a really odd field of mathematics. It seems like something that intuitively would have no real-world application. However, its real-world applications seem somewhat endless now that we have good use cases for it. So that's another amazing coincidence, but we're not done. So the Higgs boson particle was predicted mathematically in 1964 and then discovered in 2012 in the CERN's Hadron Collider. CMB radiation, we talked about this actually last week, I think. Cosmic microwave background radiation was predicted in 1948 and then discovered in 1963. The existence of Neptune was predicted in 1846, and after the mathematical prediction, we knew where to look, and then it was discovered in 1846. These are just some examples, but the point here that I'm making is if we're going to say that the applicability of mathematics is just a happy coincidence, then every single time mathematics becomes useful to the physical world is another happy coincidence. And when we have probabilities of occurrence, when something has a probability of occurring, then we could say, okay, this has a 7/10 probability of occurring, right? That's very likely to occur. It'll occur 7 times out of 10. Okay. And then something else has a 5 out of 10 times of occurring, right? The way that you find out what are the odds of them both occurring at the same time is you multiply them. And so then you got 70% here and you got 50% here. You multiply them together and you get 35 over 100. So your 70% and your 50% turns into 35%. So the point there is when you have multiple things that have a probability of occurring, all occur at the same time. To figure out the probability of them all occurring at the same time, you multiply the probabilities together and you get a smaller probability. Then you have the insanely long list of different ways that mathematics is applicable to the physical world. You multiply all those together, you would get a incomprehensibly small probability of occurrence, but it occurs. So all this to say, it is incredibly unlikely that it is simply a happy coincidence. And we know it's not from physical necessity. Before I move on, I want to be completely honest about where I currently stand in this argument. I am actually not convinced that premise 1 is an exhaustive list. I am not convinced that physical necessity, coincidence, and design are the exhaustive list in the case of this argument. And this is where my research is going to continue. So I'm presenting this argument, but I am not claiming this argument to actually be like knocked down, guaranteed currently. I'm still researching it. And I want to be transparent about that it is possible that just because it's not a physical necessity doesn't mean it's not a logical necessity. There's something else to it that I have not yet discovered. So I'm going to present the argument the way it's commonly presented today, and I'm going to be transparent with you guys that I might be missing something, and so I'm going to continue researching this argument. I know that I have a strong bias that I want this argument to be true because it would resonate so deeply with my background, but my bias cannot be something that I allow to interfere with my ability to do good reason and to do good research, to do good science, to do good philosophy. So if I find in further studies that there is something in this argument that I think is missing or that I think it's somehow misinformed, I will be updating you. That's my promise to you. It seems to be the case that it could not be from coincidence because the probability is simply too great. It's not physical necessity because that makes no sense. So the applicability of mathematics, the argument seems to be something that we've well defended. If God did not exist, the applicability of mathematics would either be a physical necessity or else a happy coincidence. It is neither a physical necessity nor a happy coincidence, therefore God exists. Now, does the existence of God get rid of the problem that the applicability of mathematics is either a physical necessity or a happy coincidence? I think it does, and I think we can defend this when we look at the scriptures. But before we do that, we need to have an earnest conversation about what the study of mathematics actually is fundamentally. So, what is math? Well, this might surprise you, but when we're talking about what is math, we're going to have a conversation about the subsets of philosophy. See, if you study philosophy, there are 4 major categories of philosophy. We have logic, we have ontology and metaphysics, we have epistemology and methodology, and then we have ethics. And out of those 4, each one branches off to different subsets. We only care about one. One of the subsets of logic is mathematics. So, when we're studying mathematics, we're studying philosophy, but we're also studying logic. Mathematics is a subset of logic. You need logic to do math, but you do not need math to do logic. So math is a subset of logic. With that being said, I want to have a conversation real briefly about the scriptures. Specifically John 1 through 3. In the beginning was the Word, and the Word was with God, and the Word was God. He was with God in the beginning. Through him all things were made. Without him nothing was made that has been made. So, John 1 through 3 is talking about Jesus Christ. And in it, John has decided to give him the title, the Word. So, I want to have a conversation. What does the Word mean? Well, the word that we have in Greek that translates in this scripture to word is the word logos. Logos is properly translated as word, but it's probably translated as a lot of things. So here's some of the translations of logos that are relatively common. Logos can mean word, it can mean thought, it can mean principle, it can mean speech, it can mean reason, and it can mean logic. Do you see it? Before I paint the picture for you, I want to point this out. The word logos, while it's translated to all of these words, it actually meant something very different to a Greek speaker 2,000 years ago. So here's what logos means. It's the divine reason implicit in the cosmos, ordering it and giving it form and meaning. So when John wrote John 1 through 3, he knew exactly what he was doing. He was being incredibly intentional. What he said was, in the beginning was the divine reason implicit in the cosmos. And the divine reason implicit in the cosmos was with God, and the divine reason implicit in the cosmos was God. He was with God in the beginning. Through him, through the divine reason implicit in the cosmos, all things were made. And without him, without the divine reason implicit in the cosmos, nothing was made that has been made. Then the word, next verse, then the word became flesh. Then the divine reason implicit in the cosmos became flesh. That's who Jesus Christ is. He's the divine reason implicit in the cosmos. So, if mathematics, fundamentally speaking, is the study of logic, and Jesus Christ, fundamentally speaking, is logic. He's the incarnation of logic. And that logic is God. And through him all things were made. Through logic, all things were made. Without logic, nothing was made that has been made. The scriptures tell us that the mind of God is where we get logic from. The mind of God is where we get mathematics from. And the mind of God is what all things were created through. All things were created through the divine reason implicit in the cosmos. So, the scriptures actually tell us that God thinks logically and mathematically, and that is how he created the cosmos. So, when we read our Bibles, we know that we should expect mathematical cohesion with the universe. That's why. Because God thinks in a mathematical way. God thinks in a logical way. And God creates in a mathematical and logical way. And that's why we can do science. And that's why we can do mathematics. And I can work on a whiteboard and figure something out that actually explains the way the universe works. Because God made it that way. That's what I have for you guys this week. God bless. Hey guys, thank you so much for watching that whole video. Since you stuck to the end, that tells me you're actually interested in the content that we're creating, which is why I want to invite you to consider doing a couple things. First and foremost, we now have enough videos on the channel that I can actually have multiple videos recommended to you from my channel. So go ahead and watch the other content. Go ahead and subscribe. Get more content like this. We are coming out with a new video every single week. We're going to have a bunch of other stuff uploaded onto the platform pretty soon here. The other thing I want you to do is consider supporting us through Patreon. We have 4 different tiers. If you go with our lowest tier, it's going to say, hey, we believe in you, we believe in your mission, we want to see you succeed. If you go with a higher tier, you're saying the same stuff, but you're also getting some cool bonuses. For example, if you go ahead and become a patron at just $19 a month, we're going to, as a thank you, send you one of these super cool necklaces. Then, if you decide to go for the next step, which is $49 a month, you'll get this necklace. You'll also get a really cool Defenders Academy tumbler. So you can go ahead and support us when you're drinking your coffee. And you'll still get a necklace. That's pretty cool, right?
And then if you go ahead and you want to support us all the way at the $99 a month tier, which would be absolutely amazing and insane, and we would love you so much for it, we would give you all this stuff. We'd also give you a free digital copy of our book and a bunch of other surprises that I'm not even going to tell you about because I want you to find out for yourself. Go ahead and prayerfully consider supporting us through Patreon, subscribing to our channel, and watching more of our videos. I love you guys. God bless.